Good afternoon, all. Yeah, welcome back to our online classes. Where, if you can remember, last week we had a discussion and we have seen them practically the factors affecting the performance of what? Solar panel. Where we have seen how that dust and what? Shading affect the performance of the solar panel drastically. Okay, yeah, welcome back. Today we are going to discuss on configuration techniques. What is configuration? That is interconnection, joining of more than one component to give us what we want based on the design. Okay, we have about three configuration. We have serial, which is series connection. We have parallel in form of cascading, in tandem, and we have combination of series and parallel connection. Where do we apply series connection? Where do we go for parallel connection? And why do we choose to go for series and parallel configuration? We're going to do it today. If we have more than one panel, which means we have to connect them together to give us the required output. Let's say we have 250 watt panel at number 250 watt, which this is the power, rated power. Power equals to 250 watt, and VOC, open circuit voltage, at 41.2 V DC, and IMP, which is maximum power current, at 8.1 amps. Okay, how many number? 8 numbers. How do we connect them? We have to know which system voltage are we operating at. If we have a solar panel, we always look at two-way to identify their system voltage. This is open circuit voltage. We have what we call system voltage. All right? So now, anything above 200 watt, from 200 watt solar panel downward, the system voltage remain 12 volts. But anything above 250 watt solar panel and above, up to 1000 watts, the system voltage is 24 volt. Of course, since we have selected 250 watt panel here, our system voltage is going to be 24 volt. All right? So now, how do you connect this solar panel? We have at number 250 watts, and then we have to do the connection. Is it series connection or parallel connection? What is series connection? A series connection is a kind of connection where if we want to consider adding up the voltage, which is open circuit voltage, you understand? That is, we go for series connection. We have two different ways of doing the connection. We can do a series connection in case when we are going to consider open circuit voltage, and there will be a situation whereby we are doing series connection only considering what? System voltage. If you can remember, I said we have a system that is having wide range of open circuit, even though in our next class when we are going to deal with solar charge controller, we will see the wide range, MPPT wide range and what have you. But now, we are going to consider the system voltage. Okay, automatically our system voltage is 24 volts. So since that is the case, we will look at our component, the remaining component, inverter, charge controller, battery, and solar panel. If our system voltage is 48 volts, which means we have to consider connecting two of these in series. Because I said in series connection, voltage is added while the current will remain constant. Okay, so which means if we connect two like this, minus here and plus here, plus here and minus here. So now, by linking this minus to this plus, we have achieved a series connection. Because when we connect, unlike poles, that is negative and positive, of different solar panels, which means we have attained a series connection, which means the system voltage now has become 48B DC. How about the current? The current will remain constant because in series connection, current is constant while the voltage is what? Added. So that is why since each panel here is having 24 volts, 24 volts, 24 plus 24, it will give us 48, which means our IMP is to remain 8.1 amps for these two. Okay, then we connect another two like this, another two, another two, plus minus. Okay, so by connecting plus and minus of different polarities, we are achieving a serial connection, right? Okay, if you look at it here, the same thing here, 48 volts, DC, and 8.1 amps. 48B DC, 8.1 amps. 48B DC, 8.1 amps. This string is series, another series, another series, another series. So now, how do we make this panel to work together? How do we make them to work together? If we consider connecting plus of this to minus of this, we have already tampered with what? The system voltage. Initially, our system voltage we are driving at 48 BDC, considering from the other component. Let me tell you one thing. System voltage start right from what? From the inverter. If inverter specification, the system voltage tell us that it is 24 volt, or 12 volt, or 36 volt, or 96 volt, we have to use that reference to all other components: battery, solar panel, charge controller, and the inverter itself. So now our inverter has indicated that the system voltage is 48 volt. So which means we have to respect that directives. That is why we are to maintain. If I consider adding another panel here, it has become 36 volt, which means it's not up to what? Sorry, it has become, this is 24, 48 plus 24, which means it has become 60 volt, which has already exceeded the limit, right? So as such, we have to do what we call parallel connection. What is parallel connection? When you have all like terminals connected together, which means plus plus minus minus, which means you have attained a parallel connection or tandem connection. And in series and parallel connection, current is added while the voltage will remain constant. While in series connection, voltage is added while the current will remain constant. Like this. We say this is plus, another plus, another plus. We can say, okay, we are going to join them together like this. Plus. And then we have another one here. We have minus. So which means this is series, another series, another series, another series. But lastly, we join all the plus terminal together to give us accumulative current. And then we join all the minus here, minus, minus, minus together. So which means we consider series and parallel connection in this scenario, which means the current will be 8.1 IMP total equals to 8.1 plus 8.1 plus 8.1 plus 8.1, 1, 2, 3, 4 plus 8.1 dash 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 to the last 8.1. Whatever we have, that is our total current. Do you understand? Do we consider it 8? No. Why did I say no? How many strings do we have? 1, 2, 3, 4. So which means we are only considering the fourth one. 1, 2, 3, 4. We are stopping here. Do you understand? I deliberately do it that way to see whether you are following me. Thank you very much for indicating your participation. Okay, so how many strings do we have? 1, 2, 3, 4. We have only 4 parallel connections. That is why we have 4 current. 1, 2, 3, 4. 8 plus 8 is 16. 32. 32 point what? 32.4. Which means 32.4 amps. This is IMPT. Okay, while the voltage will remain, B system remain what? 48. Because in parallel connection, current is added. The current is this, all right, while the voltage will remain constant, which means 48 VDC. Of course, we didn't tamper with our what? Reference system voltage. So now this is series and this is parallel. So now let us consider only parallel connection. How do we do it? Just like the way we do it this way. Let's say we have the panels, we have up to the same number. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the 8th one. Okay, which means we are going to join all the positive here together. Plus, 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 right? Okay. Okay. So now, then we connect the negative terminal together. Like this. Can you see it? All negative were what? Connected together. And then all positive were also connected together. In this case, which means we're going to have the increase in current while the voltage will remain constant. Just like here. That is to say, 8.1 times what? Times 8. Do you understand? Here we have to consider 8 because we connect 8 panels in parallel. While in this case, we only consider connecting how many panels, even though they are 8 number. But each 2 is connected together, which means each 2 is representing 1 string, which means we have how many strings? 1, 2, 3, 4. But in this case, we are cascading all the 8 panels in parallel, which means we are going to sum all the current from first one to the last one. Do you understand? All right. So now, this is it. I total is 8.1, which is the IMP, times 8 number. All right. It will give us our total, which means if we have 32 there, which means it has become 64.8. 64.8 amps. All right. And for the system voltage, B system still remain what? 48 B DC. So this is it. So in series connection, voltage is added while the current will remain constant. And in parallel connection, current is added while the voltage will remain constant. Then in series and parallel combination, both current and voltage are what? Are added. All right. So don't hesitate to join us next week for our next class on solar charge controller, which is the brain behind solar system. See you next. Thank you very much, and I hope you enjoy our class. Bye.